Hey, good morning. First of all, thank you, Jerry, and everything for having us in this historical place for ETT. A lot of good history here for America, for sure. Thank you. I'm here really to talk about uh, lifecycle management of multifunctional embedded systems. And what I mean by lifecycle management largely is how do we shrink the time if you have platforms that have to last many years to be effective in our defense industry? How do you shrink the time where you can add updates, changes, and be able to adapt very quickly, because our threats are adapting very quickly today. And at the end of the talk, I'll talk about really how, from the inner loop, how do we do that? And I'll give a case study example. So what is a multifunction system? Well, we have them all around. If I can hear a little better. We have them all around us. Here's one here, right, the cell phone. I mean, it originally started to be a phone. I guess my daughter doesn't use it that way anymore. She uses all the other applications. But it's integrated a whole bunch of applications in one platform, and it just works, right? It's pretty reliable. It's a great example of good system engineering, in my opinion. We want to take those capabilities that we see in a commercial space, right? We work very hard together in doing that. Take those capabilities and move them forward into the military. In the past, we've had the ability to do some great things in the military, build these systems that could work and solve problems, but they may be more static than they need to be today. Today, we have a lot of, as I mentioned, threats that we see, Mercury, but all our customers see, that require electronic warfare, radar, ISR, all kinds of things being fused or working together to enhance our ability to either manage the electromagnetic spectrum, or manage the battle space so our warfighters can succeed. It's so important. And we're making progress, but we have a ways to go, and we'll talk a little bit about that. So the life cycle of multifunction system, again, the cell phone. Over the past 7-8 years, a lot of different iPhones have appeared, right? They've started, and they look kind of the same, but we all know they've gotten more powerful, more capable. We can update them pretty almost in real time. Sometimes they get updated at night when we're home. I mean, OSs, all kinds of things get done. New applications pop every day. And to me, it's a fine example of what I'll call commercial MOSA, right? We know the government's trying to drive modular open system architecture across our space for a lot of real good benefits to be had. But the commercial space and the iPhone has been doing that for quite some time. We need to learn from that. What are the things that they're using in a commercial world we can leverage? It's all about leverage. In a lot of respects, we just do not have time to start over, right? We need to leverage and improve for our particular space. So let's look at another platform, the B-52 here. Hopefully you all recognize that. I think what we've seen here is a timeline from 1955 time frame to present. And what's that, about 60 years? And I think the life of that platform is going to go another 20, 25 plus years. In fact, I think I hear that one of them last week was flying around Korea again. So we have a full life cycle, if you're aware of that. Little saber rattling perhaps, but that platform still serves us well today. But do you think MOSA was a gleam of anyone's eye that put the systems together of that platform so many years ago? A lot of good purpose-built stuff at the time, but once things are built and done, they immediately become old, and they're built a set of standards to solve a set of threats at the time that are known. Look forward as far as you possibly can, but often that wasn't too far at that time. I know the platform has been upgraded in a lot of respects since then, from situational awareness and different capabilities here and there for electronic warfare and other areas. But I bet they still, because MOSA and these nuggets of things are coming together, I bet they're still not where they need to be to take care of the threats we see today and have to adapt to those almost in real time. Some of the things we've been doing in this industry, in these bodies, a lot of the smart people, VME's been around for quite a long time, helped us in this direction, right? Putting some standardization together. VPX came out again at a board level, very powerful things, and you see a lot of the things that are being worked on today are VPX-based. VME still exists and solves a lot of existing problems. Then OpenVPX came along, And it was really a top-down approach, more of a system-level approach. And I would offer that boards are like a box of rocks. They're really nice on their own and everything, but they're not solving problems directly. The only time they solve problems is when they're in a well-engineered, well-system engineering system, defined maybe with clean interfaces, with open architectures, like things like OpenVPX have started to give us as a framework for that. So let's start at the bottom just a little bit more. So what are those capabilities that we need, those open architectures, those capabilities to give us that ability to respond with a multifunction platform, again, to give our warfighters an edge, which we all need to do. You know, you have the low-end things like the Ethernet, the PCI, where you need to share data very quickly, and we've seen the maturity of those things at different levels happen over the last few years. Hopefully continue to do so. We leverage that in VPX and some of the other platforms we're doing. All, you know, very good, very good. Vita 49, you'll hear more about that today. You may have heard a little more yesterday. You know, something to give us a common protocol that will allow a common control and maybe across different payloads to allow us to adapt and change the threats in near real time, which is what we need to do these days. OpenVPX I already mentioned, but it's part of the glue and all of that to give us that system perspective. But you know, again, those are all rocks. Those are all nuggets. They're not yet fully a system. If you look at some of the government agencies, go a little further around the circle here for MOSA. CERDEC was mentioned several times and trying to really do a lot of good things in their battle space in the Army and their trucks. And this one's near and dear to my heart because my son was in Afghanistan and he rode in those trucks. And I can tell you there's not a lot of room for stuff. And you're in them sometime 24 hours, 36 hours a day doing their missions. And it's very hard to be successful, so we owe it to our warfighters to improve. So I applaud the folks like at CERDEC that are using the technologies like OpenVPX, VPX, MORA, modular OpenRF, and pulling things together into platforms that are further integrated to give us more capability, more ability to adapt to the threats we see, and also give a little space, just simple space to those poor warfighters in those vehicles. So CERDEC in the Army, Aberdeen, right? But we also have things like AFRL doing things in SOSA, things closer to the sensor. We have other, excuse me, other labs that are doing things for NavAir, again, in an open standard sense that are leveraging OpenVPX in some cases because those tools, that are there now that we can use and integrate together. But is that even enough? And I still contend that those are nuggets, right? Now, we all hear often that the software is being commoditized in the world, and I'm not sure we're getting to that yet, but a lot of the good things that are happening in these, we keep pushing the envelope and adding value in that space. But there's a lot of software, right? There's a lot of software that has to be part of that story so that we can indeed lifecycle manage things in a quick way. And portability, scalability, adaptability, if you look at what FACE is trying to do in the world of avionics, portable software, and they're looking at things not just technical but business also, right? Because we have to get those technologies to market in a way that supports the warfighter. OMS, I look at OMS really as part of a symphony. It's kind of the orchestrator, in my opinion, from what I know about it, a system of system kind of situation, pulling things together, changing and adapting, setting up the missions, doing things and controlling things as the battle space, and we have our integrated battle space, and has to be well orchestrated. OMS helps along those ways, and you're familiar with Victory, I believe. Victory is something that on the Army side helps do that with the Victory data bus. So all these things are still nuggets in my belief, and they're necessary. I don't think they're sufficient 100% yet, and let me talk about now about the inner loop a little bit. It's something that we started with in my original discussion. So what is the inner loop? So as I mentioned, multifunction systems, a lot of places where Mercury works, very complex, high-end solutions. We really have a need to do things faster and be able to adapt. And a lot of things we want to put in that newest technology, like you said. We want to introduce that. We want to leverage the standards that are in place Think about the standards as an Oreo. In my eyes, in Mercury, the standards are such that we define those interfaces very cleanly and usefully. But maybe we do some special stuff inside that Oreo and the cream that allows that open standard systems to perform in a manner that we really need them to perform. Open standards are not enough. We have to have open standard implementations that perform and satisfy the entire range of requirements we have. So Defense Science Board some time ago came out and really coined the phrase about this inner loop. In a report they did, and I think they started in 2013, it was recently introduced, that I made aware of it in 2015. They talked about the threats that they see and where the United States may be deficient in some areas, but it also talked about, you know, you have these platforms that have to last so many years. How do you update them in near real time? And I think real time is optimal, but suboptimally as fast as you can within the life cycle of these platforms. And how do you to assure to get the newest technologies, the newest capabilities, as new threats appear that you see in the battle space, how do we adapt to them? It's not good to say, yeah, 3 years from now we'll just add all those up and we'll roll them into the next next rollout, which may be 3 years away. We need near instantaneous change. And I challenge everybody here in the group that's working in these technologies to think that way, that when we build these systems, we have to make them flexible enough, often with VPX capability and the way we architect them and system engineering them, that inner loop is very important. How do we keep updating and allow ourselves to update in near real time to give our warfighters an advantage? So the case study on the inner loop in progress, Mercury thinks system all the time, really, in what they do. We build boards, rocks, as I mentioned, and very good ones, I believe, in the VPX space. And we make them work with the systems in OpenVPX very well. And we're very proud of that. We're also, we always look to that system, that balanced system. When you build a system, how do you do it in a manner to do the kinds of things that I'm talking about? And it's starting, the nuggets are coming together as I referenced the cell phone, how all those things are getting done commercially. We're starting to get the nuggets and capabilities in space to do that in the defense world. So the case study really is, and there's a white paper that we have that we'd be happy to offer any of you. We have it here that talks about in more detail this case study. We have it here today. But we had to respond to a proposal for the U.S. Air Force for a tech refresh scenario, and it was a pretty large one. Can't really tell you what it was, but of course if you saw it flying by, you'd understand what platform it was. Some of the key high-level requirements to that I can share, or there was about 9 different chassis that were inside that solution. And we had to work within the envelope of those current chassis spaces. We couldn't say, hey, I want to add another chassis here, a bigger one there, or whatever. We had to live with that envelope that was put in place many, many years ago. On top of that, we had to run with the legacy software that existed and some new applications that were anticipated, those kind of things. All those chassis, many of them were connected together. So if you think of a big platform, there's a lot of cables in place already, and the cost of replacing those and moving those around just was not acceptable. So we had to live within the wiring constraints that were there. We had to design an entire new electronic warfare suite for that solution as part of our requirement. And we had to use open standards, and one of the requirements when we had to support that inner loop concept. We had to support as best we could tech refreshes over the life of that program, some of them near real time. So Mercury, I was lucky enough to run that proposal, and what we came up with was an OpenVPX system. In fact, I think 8 or 9 OpenVPX systems that were 3U, 6U, and hybrid chassis of 6 and 3U implementations to fit in those form factors and to put the power that we needed to put in the right places in the interfaces to meet the need of the requirements. At the time, as I mentioned, electronic warfare was part of the rework. We needed to have modular capability in the RF space. What we call that internally at Mercury is OpenRFM, which is our ability to take an envelope that's compatible and compliant with OpenVPX and seamlessly put that in an OpenVPX solution So now you have, I guess I'll say, if you guys remember Ghostbusters a long time ago, dogs and cats living together, RF and digital, playing nice together in the same chassis in a modular open solution, and done in a matter from a system engineering standpoint to work first and allow that inner loop to work. And I didn't follow the program much after that. Well, I did a little bit, but day to day, Lauren Graves, who he's forgotten more about EW than I've ever learned. He couldn't be here today because he's working on some new proposals. But he told me that from award to first technical demonstration of a significant amount of that capability that we had in the RFP was about 9 months. And then we were asked to refresh later some features of that to kind of prove, does that inner loop work? And that took about 4 months. So we're starting to see the ability to do all this, take those commercial things we've learned, implement inside a system with the strong VPX capabilities, digital and RF coming together, give our warfighters what we need, that inner loop capability, so we can adapt very quickly and win the battles we need to. So we were very happy the way that turned out, and I think we were very positive. But open standards and MOSA made that happen, and good system engineering, I believe. So in summary, we're moving to the left, and again, what I mean by that is from a systems standpoint, we're looking at things more from the systems, because I contend that systems are what get the job done, and subsystems, and I know they have to have the underlying technology building them up. I'm not naive. But at the end of the day, those systems and subsystems with the software from our partners and primes and everything on top of them are needed. As we have advances, the beauty of Open VPX and VPX is how we have those advances in technology that many of you have talked about today. We can introduce them. If it can't be a near real time, like a software update or a change in technique or something, what it can be is maybe, a 6-month cycle or a year cycle and putting a new VPX card in there, doubling the processing power or something to do addition capability. So I would encourage us all to continue to think about that inner loop in everything we do. At least we can't build things that can't be changed quickly and enhanced quickly, I believe, going forward in the future, at least in this space. So it requires us to think differently and use the tools that are in place today to do that. So I encourage us all to do that to ultimately help our warfighters. So thank you.